Hi everyone, this is Christian Every Malta, and for today's video activity, I'll be solving sets of problems under AC circuit. This is our video assignment number 2 in Enhancement Course 1. And for our first problem, we have here number 3. Three parallel branches respectively contain R is equal to 300 ohms, L is equal to 0.50 Henry, and C is equal to 10 microfarad. Given the voltage V is equal to 200 sine 1000 T, determine whether the total current lags or leads the voltage and by how much. So, we have here our diagram and our given. So, the first thing that we need to do is to change the unit of these two into ohms. And to do that, we'll use this formula for, let's have first our L. So, we will change this one into inductive reactance. So, by using this formula, XL is equal to G omega L, and for our omega, based from the given, it is 1000 rad per second. So substitute 1000 here and 0.50 Henry. So I will get J500 for our inductive reactance. So for capacitive reactance, XC is equal to negative J 1 over omega C. So negative J 1000, and our 10 microfarad, let's convert that one into a farad by multiplying times 10 to the power of negative 6. So we will get negative J 100. Okay, so it is converted into ohms. So, and the next thing is to find the RMS of the voltage. The RMS of the voltage by using this formula. V RMS is equals to Vm over square root of 2, and then 200 over square root of 2, we will get 141.421 volts. And then from that, we will be able to find the current in each branches. So first, let's have the current in resistance. So we will have IR is equal to ER over R. So we have 141.421 divided by 300, and we will get 0.4714 ampere angle 0 degrees. And then the next is to find the current at the capacitance. So we have EC, XC, we have 141.421, and our XC is negative J 100. So we will get, for our IC, we will get 1.4142 angle 90 degrees. So we'll have this answer in a polar form. And then the next current is the current in the inductance. We have EL over XL, 141.421 divided by our XL is J500. We will get 0.2828 angle negative 90 degrees. So the last step is to find the total current, and to do that, we will just add all the current in the branches. So we have I total is equal to the current from the resistance add plus the current from the capacitance and the current from the inductance. So the current from the resistance, we have 0.4714 ampere angle 0 degrees plus the current at the capacitance 1.4142 angle 90 degrees plus the current at the inductance, we have 0.2828 angle negative 90 degrees. And for our total current, we will get 1.2256 ampere angle 67.38 degrees leading. So our answers are in polar form. So we have here letter D, 67.4 lead. Okay, so for our next problem, we have here number 83. A variable capacitor C is connected in parallel with an inductive coil of inductance 0.2 Henry and resistance of 10 ohms. The combination is connected across a 10 volt 60 Hz voltage source. Find the value of C, which will result in a minimum current from the source. So it is our diagram and our given. So first, let's find the value of our inductive reactance using this formula. XL is equals to 2 pi FL. So our frequency is given as 60 Hz and our L is 0.2 Henry. So our inductive reactance is equal to 75.398 ohms. So then find the value of capacitive reactance using this formula. 1 over XC is equal to XL over RL squared plus XL squared. 1 over XC is equal to our XL is 75.398 ohms or RL is 10 ohms plus 75.398 squared. The value of our capacitive reactance is 76.72 ohms. And now let's find the value of C, which is our capacitance using this formula. XC is equal to 1 over 2 pi FC. Our XC is 76.72 ohms is equal to 1 over 2 pi. Our F is given as 60 Hz and our C. So our capacitance is equal to 3.457 times 10 to the power of negative 5, that is in farad, and the traces looks for microfarad, so let's convert this one, multiply to 1 million, so we have 34.557 microfarad, and that is letter D. Okay, so for our next problem, we have here number 66. A series circuit consisting of a 30 ohm resistor and a 4 microfarad capacitor is connected in parallel with a variable inductor. For what value of inductance will the circuit be in resonance if the frequency of the source is 1200 Hz? So it is our diagram and our given. So first, let's find the value of a capacitive reactance using this formula. XC is equal to 1 over 2 pi FC, 1 over 2 pi. So our frequency is given as 1200 and our capacitance is given in microfarad. So let's convert that one into a farad by multiplying times 10 to the power of negative 6. So we will get, for our capacitive reactance, we have 33.1572 ohms. Next, let's find the value of our inductive reactance using this formula. 1 over XL is equal to XC over RC squared plus XC squared. 1 over XL is equal to our XC is 33.1572. Our RC is 30 ohms plus 33.1572 squared. For our XL inductive reactance, we have here 60.3006 ohms. So from that, we'll be able to find the inductance. So from this formula, XL is equal to 2 pi FL. We'll derive that one. L is equal to XL over 2 pi F. Our XL is 60.306 divided by 2 pi. Our frequency is 1200. So for our inductance, we will get 7.999 millihenry or 8 millihenry. So it is letter D.